right, next up we have Ben Zittlau here to talk to us about some really deep object observer updating magic in Angular. Welcome, Ben.
Okay, so yeah, my name's Ben Zittlau. I work at a local company called Jobber. I'm a software architect there. I just have a few of my various social media whatever's there. If you search for Ben Zittlau and you find something, it's most likely me. But this first slide is a demonstration of Agile, where while I was working on this presentation, I decided that getting that image to actually fit on this slide was a nice to have and not a must have, and we didn't fit that in the sprint. Okay, so what we're going to cover. So what change detection is, how it's handled in React, Vue, and Ember, so things that are not Angular, how it's handled in Angular, how Angular attempts to make it really fast, and then how the Angular compiler plays into that story. And my talks tend to not fit within the time it's supposed to fit. So if we have time, I'll go into that in a bit more depth. And if we don't, you can bug me at beers and I'll gladly talk a little bit more. So first of all, what is change detection? So as most of you might be aware, there's been a big movement towards these modern JavaScript frameworks, MVC frameworks. The best well-known ones are probably Angular, React, Vue, and Ember. And one of the key things that those frameworks bring us is the ability to basically take these things and tie them together. So they allow us to take some form of data or model or state, whichever word you want to use, and a template, so some kind of thing saying basically take this data and here's how I want to programmatically use that data. And from combining that data in a template, we get a DOM. Which is what we use in web. If you're talking about like React Native, that's not completely the full story, but it's still basically the same story. We want to take data, combine it with a template, and out of that get a DOM, which we can then style and turn into an application. There was a time when web pages were largely static. So you had one set of data and maybe one template, and you'd get one output of DOM. And generally, we handled that on the back end. Because it was static, it wasn't going to change. In a modern context where we start to build applications, an application is often things changing. People are adding things, they're deleting things, they're editing things. So as that data model state is changing, we want to be able to combine it with the template, with the things that have changed, and get updates to our DOM. So change detection is the first part of that process. Knowing that something has changed in our data so that the application can figure out what it needs to do to update the view. There's another talk I gave last year where I talked about virtual DOM, and I talked more about how that view updating actually works. So if you're interested in that, I'm pretty sure that talk is on the YouTube channel actually, so you can probably go find it there. Today I'm going to be focusing on the change detection side of it. So how do we find out that something has changed? Why are we talking about this? So personally, I find this topic really interesting. I started playing with JavaScript originally in the late 90s, and it was a very different thing from what it was today. But I really like trying to make it do things that it wasn't really meant to do. And the reality is what we use JavaScript for today fits in that bucket. We use JavaScript for things very different than what it was originally intended to be used for, and much larger problems than was intended to be used for. So the reason that we've ended up with these frameworks that have this type of tech in them is being able to make these changes and have them change in how they're rendered in the browser. It's actually really hard to get fast. And if you ever tried to do that with just like raw JavaScript or jQuery or something like that, you've probably run into that. That to actually make it feel fast and performant to the user is really hard. One of the other really neat things about it is between like the leading frameworks, they've all taken very different approaches to trying to make this work, to trying to make this feel fast and performant. And based on the decisions that they made at the very low level foundation about how these types of the change detection and view updating stuff is going to work, it actually has changed how the user experience works for you, the developer, when you're consuming those frameworks. So it's a really neat way to see how, first of all, there's no right answer to the problem yet. The frameworks are largely converging around some ideas like components and moving away from views and controllers. So there you see some convergence. But in terms of how these problems are handled, they're still handled very differently between those frameworks. And no one's really clearly winning. Every while, someone will put out a blog post saying that one is winning, and then that will last until 2 months until something changes in the other one, and now they're quote-unquote winning. So I think it's really neat to just see that there's no clear answer to this, but those decisions do actually end up impacting the decisions that cascade down from that, which is a developer you're probably used to. You make decisions, and then 3 months later, you're dealing with the consequences of those decisions. So first of all, we're going to look at how this works in React. So React uses something called virtual DOM. So again, we have our data, our model, and our template, or sorry, our data model state, our template, and our DOM. So this is what we get in a static set of data. But what happens in React is when something changes, so say something's changed in our model, it actually, every time there's a change, will effectively re-render that in the template and then add this new thing called a virtual DOM. So it creates this new thing, which is like, what would this look like with this updated data? It actually renders kind of a DOM. It stores it in memory. It's not quite the same as what the DOM is in the browser, but the same idea, the same representation. And it actually does a comparison between that new virtual DOM and what the old one used to be and sees if something changes. So it actually like sees what would come out of the template and then does this change detection on the output that would come out of that template. In Ember and Vue, they use something called observables, or if you've used Ember, if you're working with computeds, that's what's going on. In Vue, it hides it from you, so you don't actually need to know that that's going on. But basically, same story. We have our data, our model, we have a template, and we have a DOM. But what they do is they actually keep track of the fact that this data, is this place in this template, and therefore this place in the DOM. And anytime something changes, it actually cascades effectively a dirty flag all the way through your application saying this thing has changed. So it knows that it needs to go into the actual DOM output and change it, and it knows where in that DOM output it would need to go to change it. So yeah, here we add something, and here we add something, and apparently I forgot to add it, but it would show up in the DOM. Angular. So Angular is the one we're going to be talking about more today. So what Angular does is when there's a change, it keeps track of the previous state of that data and the new state of that data, and it does that for every component in your application. And then on each effectively tick, it goes through and it checks like every property on, well, technically every binding, but effectively every property on every component and compares it to its previous state and says, is this different? And one of the things that's really nice about that is it's super straightforward. It's super easy to understand. There's less complexity going on than in how Ember and Vue are dealing with it and how React are doing it. But there's some downsides to that, which I'll get to. So to summarize, change detection is how the frameworks know that something has changed and they need to update the view. So it's not actually updating the view yet, it's just knowing that something has changed. And each one of the frameworks uses a different strategy. And Angular's strategy is on every tick to go check everything and compare it to its previous state and see, has this changed? But here's the problem. How do you make that fast? So if you look at the amount of time that it takes to do that, it's this really complex formula where the amount of time it's going to take is the number of bindings you have to check and the amount of time it takes to check each one of those bindings. So if you have a very, very small app that's a single component and you only have 3 things in it, it's going to happen pretty quick. But if you imagine like trying to do something like Facebook, which is in React, but if it was in Angular, you have so much going on that page, so many pieces of data. So to propagate through everything, every little component of that page, every little part of the interface, and do these checks, it starts to add up pretty quickly. So in here, this is like a really basic drawing of a component tree. So generally, our components and apps tend to have these tree structures, and just the fact that every time we go through, we have to cascade through every single one of those, and CD just stands for change detector. Run the change detector for each one of those components to see if anything has changed. This isn't strictly true in Angular. There are things that you can do around working with immutable objects and some other strategies, but by default this would be the case if you're not going into kind of any of that more manual overriding stuff that Angular allows you to do. Okay, so for an example here, this is just like a really, really basic Angular component. So it's an article heading, pretending like, in Mark's example, we have blog posts or something like that. This is just going to be the heading for it. So it's going to have the title, and then it's going to have the author's name. So it takes one input to it, which is the article, and the article is going to have these two properties, a title and an author. So just like we were seeing before, what you do is you take data, you pass it into this, you put that data into the template, and you get an output that would be a DOM. So in AngularJS, and just to be very clear on this point, there's effectively two different versions of Angular. One is AngularJS, which is effectively Angular 1, which is the old version of Angular. If you just say Angular, you're referring to the new version of Angular, which is any Angular versions 2 or greater. So when I say AngularJS, I'm referring to the old version of Angular. So in Angular, in each one of those components, they, again, had change detectors. And this is just some pseudocode. This isn't the actual code, but this is some pseudocode written by Victor Savkin, who's on the Angular core team, to show what it did. So in here we have OP, and the OP would be like an operation. And you can see that that gets passed in. Well, I think OP is actually probably a generator, but it gets passed in. Then it has to get the getter for that effectively field or attribute. Then it gets the old value of it. Then it uses the getter to grab the new value. And then if those values no longer match, it sets the value to the new value. And then this reaction function for OP would basically be the thing that would actually go and do something in the view init. So this is basically what the change detectors in AngularJS would look like conceptually. In Angular, or Angular 2 and greater, it looks a little bit different. So the pseudocode, again, this is just pseudocode. This isn't actual code, but the pseudocode would look something like this, where it actually knows the specific attribute it's going to check. So again, in this old code, it's all generic. It fetches the field name from the object OP. It like fetches the getter. And here it knows that it wants to check author. And this code is specifically written just for checking author. It grabs the, the updated author value. It sees if it's different. If it is different, it sets it. And then, the author binding. So basically in the view, it goes and updates it. So the big difference here is that this code is written specifically to checking, the specific binding or the specific attribute or property in that component versus using this general code. Now, one of the things that's a little weird about that is that as developers, we're used to the idea that dry is good. Reusing code is good. In JavaScript, that's not actually always the case. And this is where Angular tried to be, is pretty clever in terms of how it deals with this problem, is that in JavaScript, there's this concept of monomorphism. Well, it's not only in JavaScript, but it's important for the JavaScript VM, where if I have a function where the objects are always the same shape, so if what I pass into that function always has the same attributes, it looks the same, that's called monomorphic. That function only takes one type of object. So if you're used to statically typed languages, of course, that's kind of by default how things tend to work in statically typed languages. But of course, JavaScript is not a statically typed language. So often we'll do something like this code, which can take any arbitrary object and still be able to work. And it's great because we only have to write the code once and we can use it for 1,000 different components in the application. But the problem is the object can be a different shape every time it's called. And if we do this, where we can have monomorphic shapes, then the JavaScript VM can actually take advantage of the fact that it knows what the object looks like that's coming into it, and it's actually able to optimize itself while it's running. Now, I've been talking about shapes. Of course, I also just explained that JavaScript does not have types. So for now, you're just going to have to ignore the fact that I'm talking about this thing shapes and just take my word for it that there is something called shapes. If I have time, I'll talk about that a bit more. So ignore the man behind the curtain, but this is a quote from Minko Getchev, I guess. I'm actually not sure how to pronounce his last name. But basically the key idea here is that having these monomorphic change detectors allows Angular to create these change detectors that are optimized for the JavaScript VM specifically. That, like, without understanding the JavaScript VM, doing this would make no sense. There's no reason you wouldn't just use that reusable generic code. But because they've looked at how to optimize for the actual way that the VM works and the way that the VM can speed up and optimize execution, they've built this strategy in. But where does that code come from? It'd be a real pain if every time you had a component, you had to go and write that change detector yourself for each one of your attributes, and you add a new attribute, and you have to rewrite your change detector. Of course, that's another one of the big advantages of having that generic code, is you could write it once and reuse it. So in Angular, the code that you write isn't all the code that runs. Angular actually has a compiler. Like some other frameworks like Vue, you can just like drop your code right in and that code's going to start running right away. Angular actually needs a compilation step. Now in AngularJS, in the old world, it was just, the only option was a just-in-time compiler, which basically meant when you served your Angular library with your application, actually had a compiler in it that they also served, and when your application boot, it would run a compilation step, and all that had to happen before your application could start to run. And that's where these change detectors actually come from, is that compiler looking at your components, understanding what properties there are, and it generates a compiler for, a change detector for each one of your components that way. In Angular now, so again, Angular 2 and later, they've added an ahead-of-time compiler. So there's actually a way that you can set it up now where it can do all this, in your build step before you actually deploy your code to production. So that allows you to not have to send the full compiler code, so it makes your application smaller, and also means that you're not having to do that compilation when you deploy launch the application. So when the user loads your app, it allows it to load faster because it can skip that compilation step. Okay, I'm tight on time. I'm going to go through this anyways. Okay, so why are monomorphic functions faster? So this is my very beautiful mock-up of a JavaScript object. So this would be a JavaScript object. It's got two attributes, x that has the value 1, 2, 3 stored in it, and y that has the value 7, 8, 9 in it. And that drawing there is just representation of its memory. And that on the left there would effectively be a lookup table that you could say, I want to know where the property x is, and it tells you, oh, x is at the offset 32, and then it can go look at the memory offset of 32 to find that attribute x, and that lookup table will tell me y is at the offset 64, so then it can go and find the value for y at that memory offset of 64. So this is effectively how a JavaScript object is represented in memory. If we're using monomorphic functions, what the JavaScript VM is able to do is basically skip that lookup. And it learns that, like, oh, that obj.x line of code that you have, normally you would actually have to say, okay, on this object I want property x, so it would have to go look up at what memory offset property x exists, and then look at that memory. And it's actually able to skip that, and in the actual code that executes, it will replace that with code that just looks at that offset. So it just says, okay, I'm going to replace this line that says obj.x to something that says, basically put a pointer to the object's memory space plus 32, and I'm going to fetch that. This actually is significant enough to make a fairly significant difference in performance in some cases. So that's why the monomorphic objects can be faster, is via the function that only ever takes one shape of object. It can actually replace some of this lookup code. If I took different shapes of objects, those x and y attributes might be at completely different places in memory, so it can't do that short circuit. It can't cheat and just assume that it knows where those are, because if I had A, B, C, D, E, F, those might be much farther in the memory of the object, so it can't guess where that's going to be. Now, what are object shapes? I'm going to go through this really quickly too. So I talked about shapes, and the way that it tells that it is a monomorphic function is it looks at the shapes of the objects it's guessing. And really, Chrome has pulled a fast one on us all, or more specifically V8 has, where V8 actually has classes. They're called hidden classes because we don't see them. And what it actually does is basically every blank object starts with the same hidden class, and then every time you add something to it, it actually keeps track of this tree of like, oh, if I have a blank object and I add an attribute x to it, it is now this hidden class. In this case, they call it C2, I think, or C0. For x, you offset 0, for x, you offset 0, if you add transition C2, oh, C0. So in this case, they call it C0, you add the attribute x, and now it's hidden class C1, and then you go and add the attribute y, and now it's hidden class C2. One of the really important things is it actually matters which order, because this tree is not the same. If you go blank object and add x and then add y, that's a different hidden class than if you go blank object, add y, and then add x. So just something to be aware of. So in JavaScript, in the VM, it actually does have a concept of these classes, which is kind of hiding from us, and it uses that to optimize itself by being able to tell if this thing that it got is the same shape or not. Okay, this is my contact information. Just again, I have a bunch of references that you can go check out. This talk is available online at Angular-monomorphism. Oh yeah, I had this problem last time. How do I make this big? I need that like thing so I can zoom in. I don't have it. Which?
Hold control, space, and paste.
Hold control.
Just throw it into spot.
There, that's a little bit better. Angular-monomorphism-talk.herokuapp.com. So if you want to go check out these slides or follow up on some of these links, there's some really interesting things that you can dig into, deeper about like understanding how the JavaScript VM works. One last shout out: do not do this manually. There is a very strong consensus that if you are trying to manually like make all your functions monomorphic, you're doing it wrong. Write code that is maintainable and readable. And then if you're seeing performance problems, profile it and maybe look at doing something like this. But only do this if you actually have a strong reason to do. Do not start making undry code or like manually writing all these things just to make your code run, be able to take advantage of these monomorphic functions. Yeah, that's my talk.
Any questions?
Right. So I think you kind of just touched on this there, but I guess just a little more. If I've got an app and I think this could be a problem in it, like that, it's hitting a function and it's not optimizing it. Is there kind of some steps I could go to identify this problem, and then like what would I do in terms of using these classes?
So like one option is Chrome DevTools.
Don't open my Chrome might have a lot. Oh, this is your computer. Never mind.
Don't look at my history.
Ready to drain our
So in here, you can look at performance, and you can actually run profiling. So if your page is slow, you can turn on profiling, load your page, and you can actually get some insight into which functions are being run a lot and which are slow. There are some other like V8 specific profiling tools, which are like more command line for like Node apps and things like that, that you can go into and get more insight. But I haven't played with those a lot, but they are out there, so you can track those down as well.
So I guess on the flip side, if you do see it, what would you do? Like how would you change your code then to use these classes? Would you go and just have something where it identifies the different classes and then has specific functions for each of those, or what would you do?
Well, I think there's two main things you can do. One is to use less object types. So again, if you're being a little bit sloppy, in some cases you're assigning Y first and then assigning X. In some cases you're assigning X first and then assigning Y. You could actually like potentially just make some changes that will actually make your objects be the same hidden class and be able to take advantage of this. Another option is just thinking about how many different cases you actually have, and then again just manually writing separate functions for those different cases so that they can be monomorphic in their inputs. Something like TypeScript would help with this too, because you could actually just do just for yourself as a developer, make it more clear to yourself that you are actually like using a function in a monomorphic way. If you're only accepting a single class in TypeScript, then you should be in a monomorphic mode.
Do the different VMs across like Safari, Chrome, Internet Explorer, etc., kind of all behave the same way at this deep of a level, or is this performance better in some browsers than others?
Monomorphic functions and getting optimization from that uses something called inline caches, which are used by pretty much all the modern JavaScript VMs. There are some other things I didn't talk about the V8 does in terms of what it calls this intermediate representations and optimizing compiler, which is something that happened with, I can't remember the name of it, but when they added some stuff to Chrome, I think 4 years or 5 years ago, that the other ones do not have. So that's a trick here too, is that like when you're optimizing for the VM, if the VM changes or you're going to run on a different VM, then you might not get those same benefits. Yeah.
Thank you.
So I just quick question about the DOM. You said it detects changes and then the DOM changes if you change the data. how is that detection working? Like how frequent is that? How does it check?
Yeah, so they use different heuristics to decide when to actually effectively do a tick. And they have different strategies for that in terms of how they find out. Basically, there's a effectively anytime it's data changing, it's a result of something asynchronous happening, a user event, AJAX call, something asynchronous, and they use different strategies to kind of try and wrap those asynchronous events, and then decide that like, okay, enough has happened or enough time has passed or something to decide that, okay, I'm going to redraw at this point. Again, the different frameworks will use different strategies to make that decision. Does that answer the question?
Is that something you have to set up? Is the time delay fixed and everything?
So it's all private APIs. Some of the frameworks actually allow you to override that and add your own. So for example, in Ember, you can there's an experimental project that tied to animation frame, so you can use like the request animation frame API in the browser to basically say, hit a frame rate of 60 FPS, so every 60th of a second it'll try and do a tick. But they're changing and they're optimizing that all the time, so it's not, you don't necessarily know what strategy it's going to be using. And I'm sure, like in React, for example, in the Fiber release that came out, I bet that all changed completely, how those decisions are working. Usually as a developer, you don't need to think about it.
I'll wait for time unless there's a burning question. Thank you
Okay,
very much, Ben.
Cool. Exchange.js is Edmonton's JavaScript meetup. Thanks to our sponsors, Jobber and Investopedia. Support the meetup and like and share this video, and stay informed by following us on Twitter and meetup.com. Links in the description. See you soon!